Hello, my name is Madeline Gray and I'm the Environment Manager at Ipieca. So who is Ipieca? We're the Global Oil and Gas Industry Association for Advancing Environmental and Social Performance. We were formed in 1974 at the request of the UN Environment Programme. And that was one of our key roles at the time and remains one of our key roles today, was to act as the primary channel of communication between the oil and gas industry and the UN. We're the only global association which involves both upstream and downstream business, so we operate across the full supply chain of oil and gas operations. And our vision is to advance the oil and gas industry's environmental and social performance and contribution to the energy transition in the context of sustainable development. So this is part of our 2021 to 2024 strategy, which we launched earlier this year, and it builds on our core aim, which is to advance the oil and gas industry's environmental and social performance, but also brings in the context of the energy transition and sustainable development, which is becoming more and more important today. We are a member association, as I said. We have 72 members currently, and these come from company members and associations. We work with our members to build a knowledge sharing platform where members can share knowledge and tools and practices. As I said, we have an important relationship with the UN. We have observer status at several UN bodies where we can attend events and make interventions and statements on behalf of our membership. We have a non-lobby status, so we engage with a wide range of stakeholders, including NGOs, civil society, academia, having a non-lobby status, and we don't do any advocacy. This allows us to do that. As well as coordinating with our members and the oil and gas industry, we also coordinate outside of that, so with other industry bodies. An example of this is the mining industry, for example, and the finance sector. We have 4 key themes, and our strategy provides leadership around climate action, environmental responsibility, social performance, and mainstreaming sustainability. We do this by anticipating challenges for the industry, so looking at emerging issues and horizon scanning. This enables the industry to improve its performance and allows Ipieca to inform global policy and external stakeholders. So energy is a key driver of the sustainable development and links to most of the SDGs. And the oil and gas industry is obviously a part of this global energy system and drives economic and social development. And the oil and gas industry can actually contribute across all 17 SDGs. In 2017, we launched the SDG Atlas along with IFC and UNDP, which maps out how the industry can contribute across all 17 goals by integrating them into core businesses. And a key part of this is the water goal, goal 6, which I'll talk about some of these ways it's integrated into core business later on. So the 2030 deadline to deliver the SDGs is fast approaching, and there is an increased need for action from all players across the globe to take part in delivering the SDGs. And this includes the private sector and indeed the oil and gas industry. So Ipieca, along with WBCSD, has developed the Accelerating Action SDG Roadmap, which you can see on the screen here, which outlines how the oil and gas industry can accelerate action and scale up activities to contribute to the sustainable development agenda. We've outlined 10 priority SDGs where the industry can have the biggest impact and focus its efforts. As I said, the industry can impact across all 17, but we've focused in on 10 priority SDGs. And we've identified actions that both Ipieca can take as an association, but also that members and individual oil and gas companies can take. So you can see here the eight impact opportunities, and water stewardship is outlined in number 5. So I'd like to talk in a bit more detail about water management in the oil and gas industry. So water is used throughout the oil and gas supply chain, from exploration, production, transportation, refining chemicals, and all the way through to terminals and retail. The industry withdraws fresh, brackish, and saline water, including seawater, for a number of activities. So it can be used in hydraulic fracturing and as cooling waters. There is a changing water landscape, which the oil and gas industry, but also any industry which uses water, needs to be aware of. And this was highlighted earlier this month in the IPCC report, which highlights the increasing pressure on the world's resources due to climate change, and this includes water. So there's increasing water stress and scarcity around the globe, and increasing demands on water as well. So water availability and quality may become more unreliable in a changing climate, and this is something which the oil and gas industry clearly needs to be aware of when operating in water scarce areas. In response to this, regulations have also been changing and will continue to tighten on a local level. This can create quite a confusing landscape for an operator, as these regulations can vary from location to location quite drastically. There's also a changing stakeholder response. So civil society, NGOs are all increasing their expectations on businesses to really take part in action to combat water scarcity and water stress. So in response to the changing water landscape with regards to changing regulations, there are 3 common approaches to water management, which Ipieca members highlighted. The first one is around compliance management. So this is really when you're operating in an area that already has sufficient water regulations in place, and the water is shared equally amongst users in the watershed. In this situation, often it's enough for a company to just comply with these regulations. In other situations, it might be necessary for a company to improve its operational efficiency, so to reduce freshwater use by increasing recycling and these sorts of technologies. And in other situations, it might be necessary for an oil and gas company to take part in water stewardship programs in order to help them engage with local authorities to change and strengthen regulations. Ipieca has developed the water management framework, which is a cyclical risk-based approach to water management. It's designed to be flexible, so whilst it's been developed by Ipieca and it's references the oil and gas industry, it's really designed to be high level and can be used beyond the oil and gas industry to the broader energy industry, but also to any operation really that uses water and needs to manage it. It's designed to be risk-based, flexible, as I said, collaborative, so stakeholder engagement is really a core part of it, holistic, and it follows a continuous improvement approach. So this is the core part of the framework. As you can see, there are 4 stages with stakeholder engagement and regulatory engagement at the center of it. The first stage is planning, which revolves around assessing the risks and understanding where water is to be sourced and understanding the local watershed where an operation is taking place. The second stage is implementation. So as it says, it's really around implementing water efficiency strategies and watershed and supply chain management measures that might have been identified in the previous stage. The next stage is evaluation. So this is all about collecting data and understanding the volumes and quality of water which is withdrawn and disposed of in operations. And then finally, management review assesses if the actions taken throughout the process are sufficiently assessing the risks identified in the first phase. So I'd like to highlight a few case studies from our members, which highlight some good practices from around this water management framework. The first one is from Occidental, which focuses on reusing produced water in southeast New Mexico. So this case study is located in the Permian Basin, which is in West Texas and New Mexico. This is about recycling and reusing produced water. So produced water is water which is brought to the surface along with oil and or gas during the drilling process. So it's seen as a byproduct. It can vary in quality from location to location, but often it's very high in salts. Sometimes it contains toxic elements to it, so there's a lot of treatment involved. So what Occidental have opted for in this situation is to make use of all this produced water which is coming up with the oil and reuse it within operations. So by 2019, they'd managed to reuse over 1 billion gallons of produced water, which actually replaces the fresh water which would otherwise have been used. And it can be used within operations as part of hydraulic fracturing and well completions. And Occidental are also assessing and investing in technologies to extract water from produced water, which could possibly be used for social beneficial uses outside of their own fence line. The next example I'd like to speak about comes from Shell and also is around produced water treatment. So this large ship you can see on the slide here is the Prelude FLNG platform, which is the floating liquefied natural gas platform. It's the world's largest platform, as well as the world's largest offshore facility ever constructed. And it's located 200 kilometers off the coast of Australia. And its aim is to treat produced water from the area where it's drilling for oil. It was seen as more economically feasible to develop this floating factory than it was to develop a 200-kilometer pipeline to the coast of Australia. It's also aimed to be able to move from location to location. So once it's finished in this location, it can move elsewhere in the world. The technology it uses is called macroporous polymer extraction, or MPPE. And the way it works is that produced water is passed through a bed of beads which contain an extraction liquid which allows the hydrocarbon to be absorbed into the beads. And then once the beads are fully saturated, they're then regenerated using a high pressure steam, which extracts the hydrocarbons from the beads to then be commercialized. So you can see in the diagram, the system has 2 beds, and one of them will be in regeneration mode and one of them will be in operation mode at any one time. Another case study I'd like to highlight from Shell is the reed beds in Oman. So the technology is based on reed beds, which is a natural system which allows the hydrocarbons in the produced water to be converted into CO2. The alternative to using reed beds would usually be to re-inject the water into the subsurface, and this has very high energy requirements and as such a very high CO2 footprint. So it was seen as better to use this system of reed beds. So first, the water is fed into an oil and water separator, and then the water from there moves into the reed beds. And then the treated water is finally sent into an evaporation pond where salt will accumulate and can possibly be reused later on. Shell are currently looking into how this salt can be reused. An interesting thing to note about this particular case study is the microclimate which has evolved around the reed beds. So there are now lots of species of fish and birds which were never there before. In fact, the reed beds are quite a long way from the coast, so it's a bit of a mystery as to how the fish ended up there in the first place. It's thought they were possibly brought in by birds. But the area has created a quite biodiverse biome of its own. And finally, I wanted to highlight an ExxonMobil case study, which looks at sustainable water sourcing, again in the Permian Basin. So ExxonMobil used the WRI aqueduct tool to assess the current water risk as well as projected water risk to 2040 in the Permian Basin. In the boxes there, you can see some black outlines, and those show the county boundaries in the area. And what we can really see here is that the overall water risks in the left-hand box, there's quite a range of, some areas are low to medium risk, and some areas are going up to high water risk. And what we can see in the right is the projected water stress in 2040. And most of these areas are now showing an increase in water stress. There's only actually a small area that you can see which is has a decreased water stress. So ExxonMobil used a range of data in their assessment. They used ground and surface water data as well as water data from state plans, so from New Mexico and Texas, to assess the current and projected water stress in the area. They then compared these with projected industry water demands to paint a picture of the high level water availability that could be in the future. There were some limitations to the study, as there often is. So firstly, forecasting the production of the Permian Basin, there was some uncertainty around this. So when ExxonMobil and other operators moved in, they didn't think the area would be as productive as it is. They were also relying on data from New Mexico and Texas states, which used data from 2010 to 2011. So this is quite outdated. And the result of the assessment is essentially a traffic light system. So here, each letter represents a county, and the color of the letter shows the priority for implementing water recycling technology in that county. The boxes below each county show the water source for that county, and the color of the box indicates the future water availability there. So for example, in the Lee County, you can see that it's red, and that's because the sources of water there have a low future water availability. Whereas the Loving County is green, and that's because the water sources there have a high potential future water availability. So this final slide shows the outcome of the study, really, which is that ExxonMobil had a 50% reduction of fresh water per completion by prioritizing the recycling technologies in these most water-stressed regions. And so to summarize, I'd just like to thank you for listening today. The key message really is that the oil and gas industry can contribute to the sustainable development agenda. And many of Ipieca's members are taking steps to improve water management in these water scarce areas. Ipieca has developed the water management framework, which you can find on our website. This is applicable not only to the oil and gas industry, but also beyond, to any industry really that uses and manages water. So I'd encourage you to go to the Ipieca website and have a look. And if you have any questions, please do get in touch. Thank you.